Have you ever wondered how the entire universe is spinning, and yet you feel completely still? Right now, without noticing it, you are being carried through space at extraordinary speeds. The Earth beneath you is turning faster than a jet plane, is racing around the sun, while the sun itself is drifting through the galaxy. And that galaxy is moving through the vast darkness of the cosmos. And still, nothing feels like motion. No wind, no shaking, no sense that anything is happening at all. But what if that calm is the greatest illusion you've ever experienced? What if the reason you feel still is not because nothing is moving, but because everything is spinning together perfectly? Tonight, we drift into one of the quietest and most profound mysteries of existence, a question that reaches back to the very beginning of time. Not just why the universe is spinning, but whether it was born that way. And if it was, what does that mean for everything that came after? If you've ever listened to our Valoran episode about how time might not actually flow the way we think, you may remember a similar feeling, that reality is far stranger and far more gentle than it appears. This story continues that journey. Before we go deeper, take a moment, if you'd like, to gently subscribe, leave a like, and turn on the bell. You can also join as a member if these quiet explorations help you rest a little easier. And if you're listening right now, tell me softly in the comments where you are in the world. Now, let's begin. If the universe is spinning now, then the question becomes unavoidable. When did that motion begin? Or perhaps more unsettling, did it ever begin at all? Let your thoughts drift backward, far beyond stars, beyond galaxies, beyond even the first light. Imagine a time before structure, before atoms, before anything that could be seen or touched. A moment when the universe itself was smaller than a grain of dust, smaller than anything we can truly picture. And yet, within that impossibly tiny state, everything that would ever exist was already present in potential. This is where the mystery deepens, because in that earliest moment, the universe was not calm. It was not perfectly balanced. It was not still. Something was already shifting. Scientists often describe the beginning as a rapid expansion, a sudden unfolding of space itself. But expansion alone does not explain rotation. To spin, something must carry motion in a particular direction. It must have what physicists call a kind of built-in twist, a preference, however small, that leans one way instead of another. And that is where things become quietly fascinating. Even in what we call empty space, there is never true stillness. At the smallest scales, reality behaves more like a restless ocean than a silent void. Tiny fluctuations, subtle, unpredictable changes in energy, are constantly appearing and disappearing. They are not caused by anything. They simply exist as part of the fabric of the universe. Now imagine those fluctuations not as random noise, but as tiny ripples, some of them ever so slightly uneven, ever so slightly curved. When the universe expanded in its earliest moments, those tiny irregularities did not disappear. Instead, they were stretched, amplified, carried outward across unimaginable distances. And if even a small portion of those fluctuations contained a hint of rotational motion, that motion would not vanish. It would grow, This is the first quiet clue. The idea that the universe did not need something external to start spinning. It may have inherited motion from its own earliest imperfections. And this leads us to a gentle but powerful principle that appears again and again throughout nature. Nothing that is already moving simply stops, unless something forces it to. In the vast emptiness of space, where there is almost no resistance, motion persists, continues. It carries forward through time without effort, without sound, without interruption. So if even the slightest rotational motion existed in those first fractions of a second, it would still be with us now, woven into everything we see. But how can we know this is true? How can we look back that far? The answer comes from something incredibly subtle, a faint glow that still fills the entire sky. Long after the universe began, when it had cooled enough for light to travel freely, it left behind a kind of afterimage. A soft, almost uniform radiation that exists everywhere, in every direction. It is not visible to our eyes, but with sensitive instruments, scientists have mapped it in extraordinary detail. And within that ancient light, there are patterns, tiny variations, slight differences in temperature, and more intriguingly, faint alignments that seem to stretch across vast regions of the sky. Some researchers have noticed that these patterns are not completely random. There are hints, very delicate hints, that suggest a kind of large-scale orientation, as if the universe might have a preferred direction. Not a dramatic spin like a wheel, but a subtle, almost imperceptible drift, a memory of motion. And if that interpretation is even partially correct, it changes something fundamental about how we see reality, because it suggests that the universe was not born perfectly symmetrical. It was not identical in every direction. Instead, it had a slight imbalance, a tiny asymmetry that allowed motion to exist in the first place. And once that imbalance appeared, everything else followed. Galaxies began to form, and they rotated. Stars ignited, carrying that inherited motion. Planets emerged, spinning steadily as they orbited their suns. Even the smallest particles, far below the scale of anything we can see, carry an intrinsic property that behaves like spin, as if rotation is not just a behavior, but a fundamental characteristic of existence itself. So the question slowly shifts. Instead of asking, "Who set the universe spinning?" we begin to ask something quieter, something deeper. What if spinning is not something that was created? What if it is something that simply is, a built-in feature of reality, present from the very beginning, like time or space or energy? And if that is true, then every rotation we observe, the turning Earth, the swirling galaxies, even the invisible motions within atoms, is not separate. They are all part of a single, continuous story, a motion that has never stopped, never paused, never needed to restart, a motion that began so gently that we are still inside it now, without ever feeling its beginning. And yet, one mystery remains. If the universe inherited its spin from those earliest imperfections, then why do those imperfections exist at all? Why is there any imbalance? Because in a perfectly balanced universe, nothing would ever move. And that question is where our journey continues. If even the smallest imbalance can give rise to motion, then the next question begins to unfold almost on its own. How did that imbalance survive long enough to shape everything we see today? Because in the earliest moments, the universe was unimaginably dense, unimaginably hot, and expanding at a rate so extreme that even light struggled to keep up. It would be easy to assume that any tiny irregularity would be smoothed out, erased in the chaos. And yet, somehow those faint asymmetries endured. They were not washed away. They were preserved, and more than that, they were amplified. To understand this, imagine a perfectly calm surface of water, stretched infinitely in all directions. Now imagine placing the smallest ripple into that surface. Normally, it would fade, dissolving back into stillness. But now imagine that the surface itself is expanding, stretching outward faster and faster. That tiny ripple would not disappear. It would stretch with the surface, growing larger, its pattern becoming more pronounced over time. This is very close to what may have happened in the early universe. There was a brief moment, often described as an almost instantaneous growth, where space itself expanded dramatically. Not just quickly, but explosively, increasing in size by an almost incomprehensible factor in a fraction of a second. During that expansion, any tiny irregularities, any slight differences in energy, any hint of directional motion would have been stretched across vast regions of space. And if any of those irregularities carried even the faintest rotational tendency, that too would have been stretched, not erased, but preserved on a grander scale. This helps explain something that has puzzled astronomers for decades. When we observe galaxies across the universe, we do not see random chaos. We see structure. We see rotation, vast spirals of stars turning gracefully, as if following a pattern written long before they formed. And even more intriguing, some studies suggest that these rotations may not be perfectly balanced. There may be a slight preference, a subtle difference in how many galaxies rotate in one direction compared to the other. It is not a dramatic imbalance. It is not something you would notice at a glance. But if it is real, it hints at something extraordinary. It suggests that the universe itself may carry a memory of direction, a memory of that first tiny asymmetry that was stretched across the cosmos and never fully lost. And once again, we return to that quiet principle that seems to guide everything. Motion does not need to be constantly created. It only needs to be preserved. In everyday life, motion fades quickly because of resistance. Friction slows things down. Air resists movement. Energy is lost as heat. But in the near-perfect emptiness of space, there is almost nothing to resist motion. Once something begins to move, it continues, sometimes for billions of years. This is why planets keep orbiting, why stars continue their slow rotations, why entire galaxies can spin for eons without losing their structure. They are not being pushed continuously. They are simply continuing. And this continuity leads us to a deeper realization. The universe does not behave like a machine that needs constant input. It behaves more like a story that unfolds from its initial conditions. Whatever was present in those first moments, whatever slight asymmetries, whatever tiny motions, has been carried forward ever since, shaping everything that followed. But there is still something more subtle, something even more intriguing hidden beneath this idea. Because rotation is not just a large-scale phenomenon. It exists even at the smallest levels of reality. If you could somehow observe the building blocks of matter far beyond atoms, you would find that particles themselves possess a kind of intrinsic spin. Not spin in the everyday sense like a spinning top, but a deeper property, something that defines how they behave, how they interact, how they respond to forces. It is as if rotation is not something added later, but something built into existence from the very beginning. And when you begin to connect these layers, the smallest particles, the formation of stars, the motion of galaxies, you start to see a pattern emerge. The same principle repeating across every scale. From the tiniest structures to the largest known formations, everything carries this quiet signature of motion. A tendency to rotate, to curve, to follow paths that are never perfectly straight. It is almost as if straight stillness is the exception, and motion is the rule. But why? Why should the universe favor motion over stillness? Why should imbalance exist at all? To answer that, we need to gently shift our perspective once more. Because what if stillness is not the natural state of the universe? What if perfect balance is actually unstable, something that cannot last? Imagine trying to balance a pencil perfectly on its tip. In theory, it could remain there forever. But in reality, even the smallest disturbance, a vibration, a breath of air, a tiny shift will cause it to fall. And once it falls, it chooses a direction. That direction was not predetermined in any obvious way. But once chosen, it becomes part of the system's history. The early universe may have faced a similar situation, a state of near-perfect symmetry, but not quite perfect. And that slight imperfection was enough to break the balance, enough to allow motion to begin, enough to let the universe choose directions, patterns, rotations. And once that choice was made, everything else followed. Galaxies did not need to invent rotation. They inherited it. Planets did not need to learn to spin. They were formed from material that was already moving. Even the atoms in your body carry traces of that original imbalance, that first gentle departure from perfect symmetry. So perhaps the question is not why the universe is spinning. Perhaps the deeper question is why it was never perfectly still to begin with. And as we follow that thought, another realization slowly emerges, one that connects this cosmic motion to something much closer, much more familiar. Because if rotation shaped the formation of galaxies, if it guided the birth of stars, if it was present in the very particles that make up matter, then could it also be the reason life itself became possible? That is where the story begins to turn inward, toward a spinning world, and the quiet conditions that allowed it to breathe. Now the question begins to feel closer, more personal in a quiet, almost unexpected way. If the universe was never perfectly still, if motion was present from the very beginning, then everything that exists today is part of that same continuous movement. Not separate from it, not observing it from the outside, but carried within it. And that includes something as familiar as your own world. Because before life, before oceans, Before even the first hints of atmosphere, Earth itself was already spinning. But it did not begin that way fully formed. To understand this, we need to drift forward in time, far from the first moments of the universe, into a later chapter, when gravity began to gather matter into vast clouds of gas and dust. These clouds, scattered across space, slowly started to collapse inward under their own weight. At first, the motion was subtle, a gentle drifting, particles moving toward one another almost imperceptibly. But just like before, the key was not perfect stillness. Even in these enormous clouds, there were tiny irregularities, slight differences in density, small variations in motion, and among those variations, there was always at least a hint of rotation. As the cloud collapsed, something remarkable happened. That faint rotation did not disappear. It intensified. You can picture it like this. Imagine a slow, wide swirl of water in a large basin. At first, the movement is barely noticeable. But as the water begins to funnel inward, narrowing toward the center, the rotation speeds up. The same amount of motion is now concentrated into a smaller space. This is a quiet but powerful rule of nature. When something contracts, it spins faster. So as these clouds of gas and dust shrank, their rotation increased. What began as a nearly imperceptible drift became a structured, organized motion. A spinning disk began to form, with most of the material flattening into a wide, rotating plane. At the center, pressure and temperature rose until a star was born. Around it, the remaining material continued to orbit, gradually clumping together into planets. And every one of those planets inherited that original motion. Not because something later decided to spin them, but because they were formed from matter that was already in motion. This is how Earth received its spin, not as a separate event, but as part of a long, unbroken chain that reaches all the way back to the earliest asymmetries of the universe. And once Earth began spinning, it did not need anything to keep it going. There was no engine, no external force pushing it forward. It simply continued, because nothing was there to stop it. In the emptiness of space, there is almost no resistance, no friction to slow rotation, no medium to absorb its energy. So the spin that Earth inherited billions of years ago still persists today, steady and quiet. But something else happened along the way, something that would turn this simple motion into something far more meaningful. Because Earth did not remain unchanged. As it formed, it experienced collisions, some gentle, some catastrophic. One of those collisions, massive and transformative, likely gave rise to the Moon, a large body striking the young Earth, reshaping it, redistributing its material, and altering its rotation. That event did not stop the spin. It refined it, stabilized it. Over time, the presence of the Moon began to influence Earth's motion in subtle but important ways. Gravitational interactions created tides, not just in the oceans, but within the planet itself. These interactions slowly adjusted the speed of Earth's rotation, making it more stable over long periods. And stability is where the story begins to change. Because motion alone is not enough to create complexity. It must be balanced. too chaotic and nothing holds together, too still and nothing changes. But in that narrow space between chaos and stillness, something new becomes possible. A steady rhythm, a repeating cycle, predictable pattern. Earth's rotation created exactly that. A cycle of light and darkness. A steady alternation between day and night. Not random, not chaotic, but consistent. Reliable. Gentle enough for systems to adapt, but dynamic enough to drive change. And this is where the earlier mystery begins to reconnect. Because the same principle that allowed the universe to begin moving, the breaking of perfect symmetry, also created the conditions for rhythm. And rhythm is what life depends on. Without rotation, there would be no cycle. No balance between heating and cooling. No gradual transitions. Only extremes. But with rotation, something remarkable emerges. Planet that breathes in time. A world where energy is distributed, not trapped. Where temperature shifts gently instead of violently. Where patterns can form and persist long enough for complexity to grow. And so the question quietly transforms once again. We began by asking who set the universe spinning. Then we wondered how that motion survived. And now we arrive at something deeper. What did that motion allow to exist? Because it is one thing for a universe to spin. It is another for that spinning to create conditions where something can observe it, wonder about it, and become aware of it. And that is where our journey continues. From motion to meaning, from spinning matter to living systems, from the vast silence of space to the quiet rhythm of a breathing world. As the idea settles in, something begins to feel almost inevitable, not forced, not designed in the way we usually imagine, but emerging naturally, as if the universe could not have unfolded any other way. Because once motion exists, even in the smallest form, it begins to shape everything that follows. And the more we look, the more we see that rotation is not just one behavior among many. It is a pattern that repeats with quiet consistency across every scale we can observe. From collapsing clouds forming stars, to planets circling those stars, to galaxies turning in vast spirals, the same underlying tendency appears again and again. A tendency to curve, to orbit, to rotate. It is almost as if straight motion, pure, unchanging stillness, is something the universe avoids. But why would that be? To explore this, imagine a universe that truly began in perfect symmetry. No direction favored over another. No variation in energy. No imbalance of any kind. In such a universe, nothing would distinguish one point from another. There would be no gradients, no flows, no reasons for anything to move. Every location would be identical, every direction equivalent. And in that perfect uniformity, nothing would happen. No stars would form because there would be no denser regions to collapse. No galaxies would emerge because there would be no structures to organize matter. No time, in the meaningful sense we experience it, would pass because change itself would not exist. Perfect symmetry, while elegant in theory, leads to a kind of silent emptiness. It is only when that symmetry is broken, however slightly, that the universe begins to evolve. And once it does, motion becomes not just possible but necessary, because any tiny imbalance creates a difference, and difference creates flow, and flow over time becomes motion, and motion, when constrained by gravity and geometry, becomes rotation. This is why rotation appears so often. It is not an isolated phenomenon. It is the natural outcome of systems trying to balance forces while still preserving motion. Imagine matter falling inward under gravity. If it were perfectly aligned, it might collapse straight toward a center point. But in reality, perfect alignment almost never exists. There is always some sideways motion, however small. And that sideways motion changes everything. Instead of collapsing directly inward, matter begins to curve around the center. It orbits, it spirals, it forms disks, rings, and rotating structures. Over time, those structures stabilize into the patterns we recognize: planetary systems, galaxies, clusters. So rotation is not added afterward. It emerges naturally from the combination of gravity and imperfection. And this brings us back once more to the beginning. Because if even the smallest asymmetry can lead to motion, and motion naturally leads to rotation, then the spinning universe we see today may not require a specific starting event at all. It may simply be the inevitable consequence of not being perfectly still, and perhaps more quietly, not being perfectly balanced. But there is another layer to this story, one that becomes clearer as we look deeper into how motion behaves over time. Because rotation does something unique. It stabilizes. A spinning system resists change. It maintains its orientation. It distributes energy more evenly. It creates patterns that can persist far longer than chaotic motion alone would allow. You can feel this even in simple experiences. A spinning object tends to stay upright. A rotating system tends to organize itself. Motion, when structured as rotation, becomes more predictable, more stable. And in the vast scales of the universe, that stability becomes essential. Without it, matter would collapse too quickly or disperse too easily. Structures would form and dissolve without lasting long enough to evolve into anything complex. But with rotation, something new becomes possible. Longevity. Stars can burn for billions of years. Planets can maintain steady orbits. Galaxies can hold their shape across unimaginable spans of time. And within that stability, complexity has time to emerge. Time to organize. Time to evolve. Time to transform simple systems into intricate ones. So now the mystery deepens again, but in a different direction. Because if rotation is not just a consequence, but also a stabilizing force, then it is doing more than simply moving things. It is creating the conditions for persistence. And persistence is what allows patterns to build upon themselves, which leads us to a quiet but profound realization. The spinning of the universe is not just about motion. It is about continuity, a continuous thread of movement, stretching from the earliest moments to the present, shaping structures that can endure long enough to become something more. And when you follow that thread forward, it leads somewhere unexpected, not just to stars or galaxies, but to environments where delicate balances can form, where cycles can repeat, where systems can begin to regulate themselves, where something as fragile as life can take hold. So the question is no longer only about the origin of spin. It becomes something softer, but deeper. What did spin make possible? What did this quiet, persistent motion allow the universe to become? Because somewhere along that endless continuation of movement, a spinning planet formed, stabilized, and settled into a rhythm so precise that something new began to happen upon its surface. Something that could feel time, something that could adapt to cycles, something that could exist within motion and eventually become aware of it. And that is where our story gently turns next. From the origin of spinning to its most intimate consequence. A world that breathes because it turns. By now, the pattern has become almost impossible to ignore. From the first fragile imbalance, to the expansion of space, to the formation of stars and planets, everything has carried forward the same quiet signature. Motion that never needed to be restarted. Rotation that never needed to be reintroduced. A continuity so seamless that it feels less like something that began, and more like something that has always been present. And yet, there is still one final piece of this question that gently asks to be understood. Not how spin continued, not how it shaped the universe, but how it became so deeply woven into reality itself that even time seems to follow its rhythm. Because as we observe the world around us, something subtle begins to emerge. We do not measure time in isolation. We measure it through motion. A day is not an abstract unit. It is the time it takes for Earth to complete one rotation. A year is not just a number. It is the time it takes for Earth to complete one orbit around the Sun. Even at the smallest scales, time is defined by repeating cycles, by transitions, by motion that can be counted. Without motion, time becomes almost impossible to describe. It loses its markers, its structure, its meaning, and so, in a quiet way, rotation does not just exist within time. It helps define it. This leads us to a realization that feels both simple and profound. The universe does not merely exist in time. It expresses time through motion. And if motion has been present since the very beginning, then time, as we understand it, may also be inseparable from that original imbalance, from that first gentle departure from perfect stillness. This is why the idea of a completely motionless universe feels so difficult to imagine, not just physically but conceptually, because without motion, there is no change. Without change, there is no before or after. And without that distinction, time itself begins to dissolve into something undefined. So perhaps the reason everything is spinning is not just because of how the universe began, but because spinning is part of how the universe keeps time. A kind of cosmic rhythm, a silent metronome that has been ticking since the earliest moments, not through sound, but through motion. And when you think about it this way, something shifts. The spinning Earth beneath you is not just moving through space. It is carrying you through time. Each rotation marking another cycle, another passage, another gentle step forward in the unfolding of the universe. And yet, despite all of this motion, everything feels calm, still, balanced, Because, as we touched on earlier, motion only becomes noticeable when something changes suddenly. When there is acceleration or resistance or disruption. But when motion is smooth, constant, shared by everything around you, it disappears into the background. It becomes the quiet foundation of experience rather than something you actively feel. You are not separate from the spinning earth. You are part of it, moving with it, breathing within its rhythm. And so the motion that defines your existence becomes invisible. This is the final layer of the illusion. Not that nothing is moving, but that everything is moving together so perfectly that it feels like stillness. And in that stillness, something remarkable happens. Awareness arises, a mind capable of asking questions, of wondering why the universe spins, why time flows, why anything exists at all. And perhaps that is the most beautiful outcome of this entire story. That from a tiny imbalance, from a faint asymmetry in the earliest moments, emerged not just motion, not just structure, not just stars and planets, but the ability to notice, to reflect, to become aware of the motion itself. So when we ask, who set the universe spinning? The answer becomes softer, less about a specific cause, and more about a fundamental nature. No one needed to set it spinning, because it was never truly still. The universe did not begin from perfect silence. It began with a whisper of motion, and that whisper has never faded. It continues now in the turning of galaxies, in the orbit of planets, in the quiet rotations within atoms, and in the steady passage of time itself. And as you rest here, listening, breathing, existing within this vast and gentle movement, you are not observing the spinning universe from the outside. You are part of its continuation, a brief, aware moment within an endless, silent rotation. And now, as that idea settles, we gently arrive at the next question. If this spinning motion has shaped the structure of the universe, if it has defined time itself, then what has it done to something even more delicate? Something that depends on balance, rhythm, and stability. Something that exists only within very narrow conditions. Life. Could it be that the reason life exists at all is because the universe never stopped spinning? Let's drift into that thought next. If the universe had remained perfectly still, life would never have had a chance to begin. Not because matter wouldn't exist, but because nothing would ever change. No cycles, no variation, no rhythm, and without those, life has nothing to hold on to. So now, as we gently shift from the vast scales of galaxies to something closer, something more familiar, we arrive at a spinning world that feels quiet beneath your feet. Earth. At first, its rotation might seem like just another inherited motion, one more echo of the early universe. But as we look closer, something remarkable begins to emerge. This spin is not just a leftover. It is an engine, a quiet, steady process that shapes nearly every condition required for life to exist. Because the moment a planet begins to rotate, something fundamental changes. It no longer experiences energy in a single, unbroken direction. Instead, it creates contrast, light and darkness, warmth and cooling, activity and rest. And from that contrast, something new appears, a cycle. On Earth, that cycle is so familiar we almost forget how extraordinary it is. The sun rises, the sun sets, temperatures shift gradually, winds form, oceans move, clouds gather and release rain. Everything follows a rhythm that repeats, not perfectly, but consistently enough for patterns to emerge. And life depends on those patterns. Without rotation, one side of the planet would face the sun constantly, absorbing endless heat, while the other side would remain locked in darkness, losing energy into space. The result would not be balance, but extremes. One side scorched, the other frozen. Between them, violent transitions that never settle into stability. But because Earth spins, that energy is shared. No single region holds onto heat forever. No region is left in darkness permanently. Instead, energy flows. It redistributes. It moves across the surface in waves and currents, smoothing out what would otherwise be harsh and uninhabitable conditions. This redistribution is what allows something delicate to form. Not just temperature balance, but climate. A system that is not static, but stable enough to support long-term change. And from climate, life begins to find its footing. But rotation does something even deeper than shaping temperature. It shapes time. As we touched on earlier, a day is defined by Earth's spin. But for living systems, that day becomes more than just a measurement. It becomes a guide. Inside nearly every organism on Earth, there exists an internal rhythm, a biological clock that aligns itself with this cycle of light and darkness. Plants open and close their leaves. Animals wake and rest. Even the smallest cells follow patterns of activity that are synchronized with the turning of the planet. These rhythms are not optional. They are built into life itself. And they exist because the environment is predictable. Because rotation creates a steady, repeating pattern that life can adapt to. If that pattern were chaotic or inconsistent, life would struggle to organize itself. But because it is stable, life can evolve systems that depend on it, that anticipate it, that are shaped by it over generations. So now, the role of rotation becomes clearer. It is not just moving the planet. It is setting the tempo. A tempo slow enough to allow adaptation, but steady enough to maintain order. And within that tempo, complexity begins to grow. But there is another layer to this story, one that is less visible but just as essential. Because Earth's rotation does not only affect its surface, it reaches deep into the planet itself. Far below the oceans and continents, beneath layers of rock and heat, lies a core that is not entirely solid. It moves, it flows, and as it moves, it generates something invisible but incredibly important. A magnetic field. This field extends far into space, forming a protective shield around the planet. It deflects streams of charged particles coming from the sun, preventing them from stripping away the atmosphere. Without that protection, Earth might have followed a very different path. Its air could have been lost, the surface exposed, its water slowly removed over time. But because the planet rotates, And because that rotation contributes to the motion within its core, this protective field exists. And so, once again, rotation is not just motion. It is preservation. It helps maintain the very conditions that allow life to continue. So when we ask whether spinning made life possible, the answer begins to feel less like speculation and more like a quiet certainty. Not because rotation directly creates life, but because it creates the environment where life can exist, persist, and evolve. A world of cycles, a world of balance, a world where change happens, but not so violently that it destroys everything in its path. And all of it depends on a planet that never stops turning. But now, as we follow this idea further, another question begins to emerge. Because Earth is not the only world that spins. Other planets rotate as well, some faster, some slower, some in ways that are far more extreme. And when we compare them, something interesting begins to appear. Not all spins are equal. Not all rotations create balance. Some create chaos. Some create silence. And some may quietly determine whether a world can ever come alive at all. When we look beyond Earth, the answer becomes clearer, not because other worlds are similar, but because they are not. Each planet in our solar system spins. Each carries that same inherited motion from the early cloud of dust and gas. And yet, the outcomes are dramatically different. Some worlds became calm, balanced, and capable of sustaining complexity. Others became extreme, unstable, or completely silent. And the difference, in many cases, comes down to how they spin. Let's begin with a simple thought. If rotation creates cycles, then the speed of that rotation determines the nature of those cycles. Too fast, and everything becomes rushed, unstable, constantly shifting. Too slow, and the cycle stretches into extremes, leaving long periods of imbalance. Earth, as it turns out, exists in a narrow and delicate middle. Its rotation is not random. It is just slow enough to allow temperatures to rise and fall gradually, and just fast enough to prevent either side of the planet from becoming trapped in permanent extremes. Now imagine a world where that balance does not exist. Take a planet that spins extremely slowly. So slowly that one full rotation takes longer than its orbit around its star. In such a case, one side of the planet faces the star almost continuously, while the other side remains in darkness for equally long stretches. At first, this might not sound too different from day and night on Earth, but the timescales change everything. Instead of hours, imagine months, or even years of uninterrupted daylight. The side facing the star would absorb heat without relief. The surface would grow hotter and hotter, the atmosphere thickening, trapping energy, pushing temperatures to extremes that no stable system could endure. Meanwhile, the dark side would cool relentlessly, losing heat into space, becoming colder and colder, potentially freezing any gases into solid form. Between these two extremes, there would be a narrow region where conditions might briefly allow balance. But even that region would shift slowly over time, never settling. In such a world, stable climates struggle to exist. And without stable climates, life has no consistent foundation. Now consider the opposite. Planet that spins extremely fast. Here, the cycle of light and darkness happens so quickly that the surface barely has time to respond. Temperatures may fluctuate rapidly, winds may accelerate, and the atmosphere can become turbulent, driven by constant and intense shifts in energy. The result is not calm balance, but dynamic instability. Storms that do not settle, currents that do not stabilize, patterns that form and then quickly dissolve. In such an environment, it becomes difficult for long-term systems to develop. Life depends not only on change, but on patterns that repeat long enough to be adapted to. If everything shifts too quickly, those patterns never fully form. So once again, we return to that narrow space between extremes. Not too fast, not too slow, quiet balance. And Earth almost improbably exists within that balance. But rotation does more than define the length of day. It shapes the movement of air itself. As Earth spins, different regions move at different speeds. The equator travels faster than the poles, simply because it has a greater distance to cover in the same amount of time. This difference creates subtle forces that influence how air moves across the planet. Instead of flowing in straight lines, winds begin to curve. They spiral. They form patterns that stretch across continents and oceans. This effect gives rise to large-scale systems that distribute heat and moisture around the globe. Warm air rises near the equator, travels toward the poles, cools, and then returns. Oceans follow similar patterns, carrying warm water into cooler regions and vice versa. Without rotation, these movements would be far simpler and far less effective. Energy would not circulate in the same way. Climate zones would be more extreme, less dynamic, less capable of maintaining the delicate balances that life depends on. But because Earth spins, the atmosphere becomes organized. Not chaotic, but structured. Not still, but flowing in predictable patterns. And within those patterns, something extraordinary happens. Stability emerges from motion. A stable climate does not mean unchanging conditions. It means conditions that change within limits. Conditions that fluctuate, but do not collapse. Conditions that allow ecosystems to form, adapt, and persist over long periods. And once again, we see the same theme repeating. Rotation is not just movement. It is controlled movement. Movement that creates patterns. Patterns that create stability. And stability is what allows life to take root. So when we compare Earth to other worlds, the conclusion becomes quietly unavoidable. It is not enough for a planet to spin. It must spin in the right way, at the right speed, with the right balance. And that balance is rare, which leads us to a deeper question. If rotation is so critical to creating habitable conditions, then how often does this balance occur? How many worlds in the universe spin in just the right way? And perhaps more intriguingly, is Earth's balance simply a coincidence? Or is it the natural outcome of deeper laws that guide how planets form and evolve? As we continue, we begin to see that rotation does not just influence a planet's surface. It reaches deeper still into the hidden structures that protect life itself. Into forces you cannot see, but without which nothing here would survive for long. beneath everything we've explored so far. The light, the atmosphere, the shifting winds. There is another layer, hidden deep within the earth, quietly shaped by rotation. And without it, life as we know it might never have survived long enough to exist. Because far below your feet, beyond the crust, beneath the oceans and continents, there is a region that never rests. A vast, slowly moving ocean of molten metal. The Earth's outer core. It does not sit still. It flows. It churns. It moves in complex patterns driven by heat rising from the planet's interior. And as it moves, something extraordinary happens. It generates a magnetic field. You cannot see this field. You cannot feel it directly, but it surrounds the entire planet, stretching far out into space like an invisible shield. And every moment, it is quietly protecting the world you live in, because the sun is not as gentle as it appears. It constantly releases streams of charged particles, moving outward at tremendous speeds. If these particles were allowed to reach Earth's surface freely, they would gradually strip away the atmosphere, eroding it over time. The air you breathe, the water that fills the oceans, all of it would slowly be lost to space. This is not just a theory. It has already happened elsewhere. There are worlds that once may have held thicker atmospheres, perhaps even water, but without a strong magnetic field, they could not hold on to them. Over time, the constant flow of solar particles wore them down, leaving behind cold, thin, silent landscapes. But Earth remained protected, and that protection is deeply connected to motion, because the magnetic field is not simply there by chance. It is generated by the movement of molten metal inside the planet, and that movement is influenced, shaped, and stabilized by Earth's rotation. As the planet spins, it helps organize the flow within the core. It introduces structure into what would otherwise be chaotic motion. And that structured motion sustains the magnetic field over vast stretches of time. Once again, we see the same quiet pattern. Rotation creates order. Order creates stability. And stability allows something fragile to endure. Without this invisible shield, Earth's atmosphere might not have survived. Without the atmosphere, there would be no stable surface water, no protection from radiation, no environment where life could evolve over billions of years. So in a very real sense, rotation does not just help life begin. It helps life survive. But there is another subtle influence of rotation, one that extends far beyond the surface and the core, into the very orientation of the planet itself. Because Earth does not simply spin randomly in space. Its axis, the imaginary line around which it rotates, is tilted. Not dramatically, but enough to matter. This tilt creates something we experience every year, often without thinking deeply about it. Seasons. As Earth orbits the sun, different parts of the planet receive varying amounts of sunlight at different times. The angle of light changes. The duration of daylight shifts. Temperatures rise and fall in long, gentle cycles. And these cycles add another layer of rhythm to the world. Not just daily patterns, but yearly ones. Longer cycles that influence ecosystems, migrations, growth, and rest. Plants bloom and fade. Animals move and return. Entire systems synchronize themselves not just to the day, but to the year. And once again, this is only possible because the planet rotates in a stable, consistent way. If the axis were wildly unstable, if the orientation shifted unpredictably, these seasonal patterns would break down. Climates would fluctuate too dramatically. Environments would struggle to remain consistent long enough for complex systems to adapt. But because Earth's rotation is steady, its tilt remains relatively stable over long periods. And that stability creates layered rhythms. Day and night, warm and cool, season to season, each layer interacting with the others, forming a complex but balanced system that supports life in countless forms. So now, as we gather these pieces together, the picture becomes clearer. Rotation is not just one factor among many. It is a foundation. It shapes the surface. It organizes the atmosphere. It stabilizes the interior. It protects the planet. Creates cycles. It defines time in a way that living systems can follow. And all of this arises from a single, continuous motion inherited from the earliest moments of the universe. But perhaps the most remarkable part is this. All of these effects are quiet. There is no constant reminder that the Earth is spinning. No sensation that something extraordinary is happening beneath you. The processes that sustain life operate gently, steadily, without drawing attention to themselves. And because of that, they are easy to overlook. It is easy to think of rotation as just a fact, something that happens but does not truly matter, until you imagine a world without it. A silent world, a still world, a world without cycles, without protection, without rhythm. And suddenly, the absence of motion becomes far more striking than its presence. So when we ask whether spinning made life possible, the answer continues to deepen. Not just yes, but in ways so fundamental that without it, the question of life might never arise at all. And yet, as we continue outward, another mystery begins to form. Because if rotation shapes habitability so precisely, if it must exist within such a delicate range, then what happens at the extremes? When spinning becomes too powerful, too intense, too fast to remain gentle? At what point does the same motion that nurtures life begin to distort something far stranger? Not climate, not atmosphere, but time itself. As we continue this quiet journey, something subtle begins to emerge, a realization that the same gentle motion that sustains life can also, under different conditions, begin to transform reality in ways that feel almost unimaginable. Because rotation, as calm and balanced as it feels here on Earth, does not have a fixed nature. It exists on a spectrum, and as that spectrum stretches toward extremes, the effects of spinning begin to change. They deepen, they intensify, they move beyond shaping environments, and begin shaping the very structure of space and time itself. But before we reach those distant and powerful examples, it helps to pause and notice something closer, something that quietly connects our everyday experience to these larger cosmic effects. Because even here on Earth, rotation is already doing something extraordinary with time, just in a way that is far too subtle to notice without careful measurement. As the planet spins, Different points on its surface move at different speeds. Near the equator, the ground beneath you travels faster, completing a larger circle in the same amount of time. Near the poles, that motion is slower. And while the difference may seem small, it is enough to create a measurable effect. Time itself passes slightly differently depending on where you are. Not by seconds or even milliseconds in a way you could feel, but by tiny fractions so small that only precise instruments can detect them. And yet they are real. The faster you move, the more time stretches, ever so slightly. The deeper you are within a gravitational field, the more time slows. These are not abstract ideas. They are woven into the structure of reality, and they reveal something profound. Time is not separate from motion. It is influenced by it. So even here on this calm, spinning world, rotation is already shaping how time flows, just gently, quietly, almost invisibly. But now imagine increasing that rotation, not just a little, but dramatically. Imagine a world that spins not once every 24 hours, but dozens, hundreds, even thousands of times within the same span. At first, the effects would be physical. The surface would experience intense forces. The atmosphere would stretch, winds would accelerate, structures would struggle to remain stable. But beyond a certain point, something deeper begins to happen. The connection between motion and time becomes stronger, more noticeable, more profound, because as rotation increases, it begins to interact with the fabric of space itself. Not metaphorically, but physically. Space and time are not separate entities. They are part of a single, interconnected structure. And when massive objects spin, they do not simply move within that structure. They influence it. They gently twist it. This effect is almost impossible to notice at everyday scales. Earth's rotation creates only the faintest trace of this distortion. But the principle is still there. The faster and more massive the spinning object, the stronger the effect becomes. And so, as we move outward into the universe, we begin to encounter objects where this quiet influence becomes impossible to ignore. Stars that spin far faster than our sun, remnants of massive stars that have collapsed into incredibly dense forms. Objects so compact, so energetic, that their rotation begins to do something extraordinary. They do not just move through space. They begin to drag space along with them. It is a strange idea, but a consistent one. Imagine placing a spinning object into a thick fluid. As it rotates, it pulls the surrounding material into motion. It creates a subtle swirl, a distortion that spreads outward from its surface. Now imagine that instead of a fluid, the object is embedded in spacetime itself. As it spins, it does something similar. It creates a gentle twisting effect, a kind of cosmic whirlpool where the very structure of reality is influenced by motion. And in those regions, time behaves differently. It slows, it bends, it follows paths that would not exist without that rotation. So the same principle that allowed life to emerge on a spinning planet, the same continuity of motion that began with the earliest asymmetries, extends all the way to the most extreme environments in the universe. From gentle cycles to profound distortions, from the rhythm of day and night to the bending of time itself. And suddenly, the story feels more connected than ever. Because the spinning of the universe is not just about structure or life or motion. It is about how reality behaves at every level. A single principle, expressed in different ways depending on scale. Soft and nurturing here, intense and transformative elsewhere. And as we approach those extremes, one final question begins to form. If rotation can shape life, and if it can bend time, then what happens when it reaches its absolute limits? When spinning becomes so powerful, so intense, that it no longer just influences reality, but begins to reshape it entirely. That is where we are going next, toward the edges of motion, toward the places where spinning no longer feels gentle, but becomes something far stranger. Something that challenges how we understand time, space, and existence itself. As everything begins to come together, a quiet understanding starts to settle in, not as a sudden realization, but as something gentle, something that feels almost inevitable once you see the pattern clearly enough. Because the deeper we follow this idea, the more it becomes clear that life did not simply appear on a spinning planet by coincidence. It emerged within a system that was already shaped, guided, and stabilized by motion. A motion that was never chaotic, never random in the way we often imagine, but structured just enough to create balance without removing change. And that balance is where life finds its place. Because life does not thrive in extremes. It does not emerge in perfect stillness, and it does not survive in constant chaos. It exists in between, in that narrow, delicate range where systems are stable enough to persist, yet dynamic enough to evolve. And rotation, quietly and continuously, creates exactly that environment. It prevents one side of the planet from collapsing into endless heat or endless cold. It ensures that energy moves, that air circulates, that water flows. It builds patterns that repeat, not perfectly but reliably enough for living systems to adapt to them. And over time, those systems do more than adapt. They synchronize. They begin to expect the rhythm. They build themselves around it. Every sunrise becomes not just a change in light, but a signal. Every sunset, a transition. Every cycle, a cue that guides behavior, growth, rest, and renewal. And in this way, life does not exist separate from the spinning world. It is woven into it. It listens to it, follows its pace, and perhaps most remarkably, it reflects it. Because even within your own body, there are rhythms that mirror this larger motion. Patterns of activity and rest, cycles of energy and recovery, internal processes that rise and fall in quiet synchronization with the turning of the planet beneath you. You do not feel the earth spinning, but your body responds to it constantly. And this brings us to a deeper, more intimate connection. Because the motion that began long before stars existed, the motion that shaped galaxies, the motion that formed the earth, is still present within you now. Not as something external, but as part of the environment that made your existence possible. A continuous thread, stretching from the earliest moments of the universe to this exact second. And when you follow that thread all the way back, the story becomes beautifully simple. The universe was never perfectly still. A small imbalance allowed motion to exist. That motion persisted, expanding, shaping structure, forming stars and planets. On one of those planets, rotation created balance, cycles, and stability. And within those conditions, life emerged. Not in spite of motion, but because of it. So when we ask, did spinning make life possible? The answer is no longer just yes. It becomes something deeper. Spinning made stability possible. Stability made cycles possible. Cycles made adaptation possible. And adaptation made life possible. Each step connected, each layer building upon the one before it. And all of it beginning with that first quiet departure from perfect symmetry. But as gentle as the story has been so far, there is still one final turn waiting for us. Because everything we have explored exists within a comfortable range. A range where motion is balanced, where its effects are subtle, where it nurtures rather than overwhelms. But the universe does not stop there. Beyond this calm region, rotation continues. It grows stronger, faster, more intense, and eventually it reaches a point where it no longer simply supports reality, but begins to distort it, where spinning is no longer just about cycles and balance, but about bending the very structure of space and time itself. And that is where our journey moves next, into the most extreme expressions of motion, into places where time does not flow the way it does here, where rotation becomes so powerful that it changes what it means for a moment to pass. So as you rest here, carried gently by the steady spin of the earth, take a quiet breath, and let that motion fade once more into stillness. Because what comes next is stranger, deeper, and far more powerful than anything we have felt so far. There is a point where spinning stops feeling gentle. A point where motion no longer simply shapes climates or stabilizes planets, or creates the quiet rhythms that life depends on, but begins to reach deeper into the structure of reality itself. Because as we move beyond Earth, beyond even the calm rotation of stars, we encounter objects that carry motion to an entirely different scale. Objects where spinning is no longer measured in hours, but in fractions of a second. Objects so dense, so extreme, that their rotation does not just move them through space. It begins to influence space and time together. To understand this, imagine again that familiar idea. Space-time is something smooth, like a vast invisible fabric stretching in all directions. Under normal conditions, objects move across this fabric without changing it in any dramatic way. But when something becomes incredibly massive, it presses into that fabric, creating a kind of curve. And when that massive object begins to spin, it does something even stranger. It drags the fabric with it, not metaphorically, but physically. This effect is subtle around Earth, almost impossible to notice without precise instruments. The planet does twist space-time slightly as it rotates, but the effect is so small that it remains hidden from everyday experience. Time flows almost uniformly. Space feels stable. Everything appears calm. But now, imagine increasing the mass. Imagine compressing an entire star into a sphere no larger than a city. And then imagine that sphere spinning, not once every 24 hours, but hundreds of times every second. These objects exist. They are known as neutron stars, and when they spin, the effect is no longer subtle. It becomes intense, because the combination of extreme density and rapid rotation creates a powerful distortion in spacetime. The fabric is no longer just gently curved. It is twisted, pulled along in the direction of the spin, like a current forming in an otherwise still ocean. And within that current, time behaves differently. If you could somehow observe a clock near such an object, you would find that it does not tick at the same rate as a clock far away. Time slows down in stronger gravitational fields, and when rotation is added to that gravity, the effect becomes even more pronounced. The faster the spin, the deeper the distortion. So now, the connection we hinted at earlier becomes clear. Motion does not just exist within time. It shapes it, and in extreme cases, it can bend it. But there is an even more fascinating detail hidden within this phenomenon. Because near these rapidly spinning objects, it becomes impossible to remain completely still. Even if you tried to hover in place, space-time itself is being pulled along. You would be carried with it not by force in the usual sense, but because the very stage on which motion occurs is moving. It is as if the universe itself is gently turning beneath you. This effect is often described as a kind of dragging, a subtle but unavoidable pull that affects everything nearby. Light, particles, even the flow of time, all begin to follow the rotation. And this leads to a strange realization. Stillness in such environments is not just difficult. It is impossible, because when spacetime itself is in motion, everything within it must follow. So now, the idea we explored at the very beginning returns, but in a deeper form. We wondered how everything could be spinning, and yet feel still. Now we see the reverse. In some places, everything is so strongly affected by motion that stillness cannot exist at all. And somewhere between those two extremes lies the world we know, a place where motion is perfectly balanced, where rotation is constant but gentle, where space-time is influenced but not overwhelmed, where time flows steadily enough for life to exist without noticing the deeper currents beneath it. But as we continue outward, the story does not stop with neutron stars. Because there are objects even more extreme. Objects where rotation reaches its ultimate expression. Where space-time is not just twisted, but drawn into something like a whirlpool. And near those objects, the distinction between motion and time begins to blur even further. Moments stretch, paths curve in unexpected ways. And the idea of a simple, steady flow of time begins to break down. So now the question becomes even more intriguing. If spinning can bend time, then how far can that effect go? Can it stretch time indefinitely? Can it trap it? Can it create regions where the normal rules no longer apply? To answer that, we must move closer to the most powerful spinning structures in the universe. Places where motion reaches its limits. Places where reality itself begins to behave in ways that feel almost impossible, and yet are completely real. And as we approach them, something else begins to happen. The calm, steady rhythm we've been following, starts to change. Not abruptly, but slowly, gently, as if the universe itself is preparing us to see something deeper, something that has been hidden within motion all along. As we move closer to the most extreme regions of the universe, the nature of spinning begins to change in a way that feels almost unreal. Not because the laws of physics stop working, but because they begin to reveal just how flexible reality truly is when pushed far enough. Because beyond neutron stars, beyond even the most rapidly spinning remnants of collapsed stars, there exist objects where rotation and gravity combine into something far more powerful. These are black holes, and when they spin, they do not simply influence spacetime. They dominate it. Imagine once again that invisible fabric, not as something distant, but as the very structure in which everything exists. Around a non-spinning mass, that fabric curves inward, creating a kind of well. But when the object spins, the situation changes completely. The fabric does not just curve, it twists, wrapping around the object like a slow but unstoppable vortex. And the faster the spin, the stronger that twisting becomes. Near a rapidly spinning black hole, this effect reaches a level that is difficult to fully imagine. Space itself begins to rotate, not in the sense that objects are moving through it, but that the space they occupy is being pulled along, forced into motion. This region, just outside the boundary of the black hole, becomes a place where nothing can remain at rest. Even light, which normally travels in straight paths, is caught in the rotation, its trajectory bending as it tries to escape the twisting spacetime. And within this region, something extraordinary happens to time. It slows, not gradually in a way that feels smooth and predictable, but dramatically, depending on how close you are to the source of that rotation. If you could observe two identical clocks, one far away and one near the spinning mass, you would see them fall out of sync. The closer clock would tick more slowly, its moments stretching, its flow of time altered by the intense curvature and motion of spacetime around it. But there is a boundary where this effect becomes even more profound. A region where rotation becomes so dominant that the normal idea of standing still simply disappears. In this region, every possible path forward leads in the direction of the spin. It is not that something is pushing you. It is that the structure of spacetime itself no longer allows any other option. You are carried along because the universe around you is moving. And this leads to one of the most fascinating ideas in all of physics. That motion, when extreme enough, does not just occur within spacetime, it reshapes the possible paths that exist within it. It defines what directions are even available. So the question we began with, can spinning bend time, now feels almost understated. Because at these scales, spinning does not just bend time. It reorganizes it. It changes how events can unfold. It alters the relationship between cause and effect in subtle but measurable ways. And yet, all of this arises from the same principle we have followed from the beginning. A small imbalance, a continuation of motion, a tendency toward rotation that never stopped, never reset, never needed to be reintroduced. It simply grew scale by scale until it reached these extremes. And what is perhaps most remarkable is that the same underlying idea connects everything. The spinning earth that gives you day and night, and the spinning black hole that twists space-time into a vortex are not separate phenomena. They are different expressions of the same law, the same continuity of motion playing out under different conditions. Gentle here, extreme there, but always present, always shaping reality in some way. And now something even more subtle begins to emerge. Because if rotation can alter time, then time itself is not as fixed as it feels. It is not a constant flow that moves independently of everything else. It is influenced, shaped, adjusted by motion, by gravity, by the structure of space-time, which means that the now you experience is not universal. It is local. It depends on where you are and how you are moving. And this brings us back quietly to where we began. You feel still. You feel as though time passes evenly, calmly, without distortion. But that is only because you exist within a very specific range of motion, a very gentle part of the cosmic spectrum where everything is balanced just enough to feel stable. But beyond that range, time begins to stretch, to bend, to behave in ways that feel unfamiliar. And yet, it is all part of the same system, a system where motion and time are inseparable. So now, as we continue, one final question begins to form. If spinning can shape time, if it can bend it, stretch it, even reorganize the paths events can take, then what does that say about the nature of time itself? Is time something that exists independently, or is it something that emerges from motion? Something created moment by moment by the spinning structure of the universe. That is the final mystery waiting for us. And as we move toward it, the story begins to slow, not because it is ending, but because it is settling into something deeper, a reflection, a quiet understanding that what we have been exploring is not just motion in the cosmos, but the rhythm of existence itself. As the idea settles deeper, something begins to shift in how we think about time, not as something that flows independently, but as something that is quietly shaped by the motion of the universe itself. Because if spinning can bend time, stretch it, slow it, and even guide the paths that events can take, then time is not the fixed background we once imagined. It is responsive. It is dynamic. It is part of the same system as motion. And this realization leads us to a place that feels both strange and strangely calm at the same time, because it suggests that what we experience as a steady, continuous passage of moments is actually a very specific condition, a gentle region within a much broader range of possibilities. Here on Earth, everything is balanced just enough. The planet spins at a moderate rate. Gravity is strong, but not overwhelming. Motion is constant, but smooth. And within this narrow window, time appears steady, predictable, reliable. But that steadiness is not universal. It is local. It belongs to this environment. And when we step outside of it, even just in thought, the nature of time begins to change. Imagine moving closer and closer to one of those extreme spinning regions we described earlier. Not all at once, but gradually. First, nothing feels different. The stars look the same. Space appears calm. But as you approach, something subtle begins to happen. Processes slow. Not in a way you would feel internally, because everything around you slows together, but in comparison to a distant observer, your time begins to stretch. A second for you becomes longer than a second for them. And the closer you move, the stronger this effect becomes. To an outside observer, it would appear as if you are moving more and more slowly, your actions stretching out, your motion becoming elongated in time. But from your perspective, everything feels normal. Your thoughts flow as usual. Your movements feel unchanged. This is one of the most fascinating aspects of how time behaves. It is not something you can feel directly changing. It is something that only becomes apparent when compared across different regions of motion and gravity. And this leads to a quiet but profound conclusion. There is no single universal clock, no master timeline that everything follows equally. Instead, time is experienced differently depending on where you are and how you are moving, and rotation plays a key role in shaping those differences. Because when massive objects spin, they do more than curve space-time. They create direction within it. They introduce a kind of flow, a subtle movement that influences how time unfolds locally. And in extreme cases, this influence becomes so strong that it begins to challenge our most basic intuitions. Because if time can slow down, could it stop? If motion can stretch moments indefinitely, could it trap them? These are not just philosophical questions. They emerge naturally from the same principles we have been following. In regions of extremely strong gravity and rapid rotation, time can slow to such an extent that, from the outside, it appears to almost freeze. Events near the boundary of a black hole, for example, seem to stretch endlessly, never quite completing from the perspective of a distant observer. And yet, locally, those events continue. Time does not stop for the one experiencing it. It only appears to stop from another frame of reference. So once again, we return to that idea of perspective. Just as motion is relative, so is time. What feels like a steady flow to you may appear stretched or compressed to someone else, depending on their motion and position within space-time. And rotation is one of the key factors that creates these differences. It introduces asymmetry. It creates regions where space-time behaves differently. It defines environments where time can flow at different rates. And so, the spinning universe is not just shaping matter, it is shaping experience itself. It determines how moments pass, how sequences unfold, how cause leads to effect. And yet, despite all of this complexity, everything remains consistent. The laws do not break. They do not contradict themselves. They simply allow for variation, a flexibility that lets the universe behave differently in different places, while still remaining unified as a whole. And this brings us to a final, quiet realization. The calm, steady time you feel right now is not the absence of complexity. It is the result of perfect balance. A balance between motion and gravity, between rotation and stability. A balance that allows time to feel smooth, even though beneath that smoothness lies a vast range of possibilities. And as we move toward the end of this journey, the question gently transforms one last time. Not just can spinning bend time, but is time itself a reflection of spinning, a byproduct of motion, a measure of change created by the continuous rotation of everything that exists? And if that is true, then every moment you experience is not separate from the universe's motion. It is part of it, a single point within an endless, unfolding rotation. And as that thought begins to settle, the story slows. Not because it has reached an ending, but because it has reached a kind of stillness. A stillness that exists not in the absence of motion, but in the perfect harmony of it. As everything begins to quiet, the final layer of this story reveals itself not as something dramatic, but as something deeply calming, almost gentle in its truth. Because after traveling from the first motion of the universe, through the formation of stars, through the spinning of Earth, and into the extreme twisting of space-time itself, we begin to see that all of it is connected by a single continuous idea. Not force, not chaos, but balance within motion. Because even in the most extreme places, where rotation bends time and space into unfamiliar shapes, the same laws still apply. Nothing is breaking. Nothing is random. Everything follows a quiet consistency. And that consistency is what allows the universe to remain understandable, even when it becomes strange. But now, instead of looking outward, we can gently turn inward again, back to where you are, right now, resting on a spinning world that feels perfectly still. Because the most remarkable part of this entire journey is not that spinning can bend time. It is that, despite all of that motion, your experience remains calm, steady, and continuous. You do not feel time stretching. You do not feel space twisting. You feel stillness. And that stillness is not an illusion in the sense of being false. It is a result of everything around you moving together in harmony. The earth spins and you move with it. The atmosphere moves and you breathe within it. The solar system travels and you are carried along without resistance. There is no sudden change, no interruption, no force acting differently on you than on everything else nearby. And because of that, motion disappears into the background. It becomes the foundation of experience rather than something you actively notice. This is why the universe can be in constant motion and still feel peaceful, because peace in this sense is not the absence of movement. It is the absence of conflict within movement. Everything is aligned. Everything is flowing together. And so, even though you are part of an immense, ongoing rotation that began billions of years ago, it feels like stillness. And perhaps that is the final insight this journey offers. That stillness and motion are not opposites. They are perspectives. From one point of view, everything is moving. From another, everything is calm. And both are true at the same time, because you are not separate from the motion. You are included in it. You are carried by it. You exist within it so completely that it becomes invisible. And when you begin to see it this way, something shifts. The spinning of the universe is no longer something distant or abstract. It is not just galaxies turning far away. It is not just planets orbiting stars. It is something you are already part of. Every moment you exist, you are moving through space, carried by layers of motion you never feel. And yet, within that motion, you experience continuity, a steady flow of time, a sense of presence that feels grounded and calm. And that is the quiet beauty of it all. that the same motion that bends time near black holes, that twists space-time in distant galaxies, is also the motion that gently carries you from one moment to the next without disruption. It does not need to be noticed to be real. It does not need to be felt to be meaningful. It simply continues. And so, as we reach the final stretch of this story, the question we began with begins to soften. Not disappear, but transform. The universe was not set spinning by a single moment or a single cause. It has always been in motion, and that motion has shaped everything that followed, from the largest structures to the smallest details of your experience right now. And yet, within all of that, there is calm. There is stillness. Not because nothing is happening, but because everything is happening together. And as that thought settles, we arrive at the final reflection. A place where the story slows, where the motion becomes quiet once again, and where the feeling of being carried gently through the cosmos becomes something you can rest within. Now, as everything gently settles, we arrive at the quiet edge of this journey, where the questions no longer feel urgent, and the answers no longer need to be sharp or precise. Because what began as a mystery about why the universe is spinning has slowly become something softer, something more reflective. Not just an explanation of motion, but an understanding of how deeply that motion is woven into everything we experience. And here, at the end, we return to the simplest feeling of all: stillness. The same stillness you felt at the beginning. The same calm, unmoving presence that seems to surround you right now. And yet, you know something now that changes it. You know that beneath that stillness, everything is moving. Not chaotically, not violently, but smoothly, continuously, without interruption. The earth is turning beneath you, carrying oceans, continents, and every living thing in a slow, steady rotation. The moon is drifting, gently shaping that motion over time. The sun is moving through the galaxy, bringing the entire solar system along with it. And the galaxy itself is turning, part of a much larger cosmic flow that stretches far beyond what we can see. And all of it is happening right now, without sound, without sensation, without any demand for your attention, because you are not separate from it. You are part of the motion. And when everything moves together, motion becomes invisible. It becomes peace. This is the final transformation of the question. At the beginning, it felt like something needed to be explained. Why is everything spinning? What caused it? What started it? But now, those questions begin to dissolve into something quieter. Because the answer is not a single event or a single cause. It is a continuity, a gentle unfolding that has never stopped. The universe did not need to be set in motion. It was never perfectly still. And that slight, almost imperceptible imbalance was enough. Enough to allow movement. Enough to allow structure. Enough to allow time. And eventually, enough to allow you. So now, instead of asking why the universe is spinning, you can simply notice that it is, that you are inside it, that every moment you experience is carried forward by that same ancient motion. And there is something deeply calming about that realization, because it means that nothing here is isolated. Nothing is disconnected. the breath you take, the moment you feel, the quiet awareness you have right now. All of it exists within a system that has been moving uninterrupted for billions of years. You are not separate from the universe's motion. You are a continuation of it, a brief, aware expression of something that has been unfolding since the very beginning. And just like everything else, you are carried forward gently, moment by moment, without needing to understand every detail, without needing to feel every motion. The spinning continues, whether you notice it or not. Time continues, whether you measure it or not. And within that continuity, there is space for rest. Because the universe does not rush. It does not strain. It does not force its motion. It flows, and you are part of that flow. So as this story comes to a close, there is nothing left to solve. No final mystery that needs to be answered. Only something to feel. A quiet awareness that the stillness you experience is not the absence of motion, but the harmony of it. Everything moving together. Everything aligned just enough to create this moment. And as you rest here, gently carried by the spinning earth, you can let that awareness soften even further. You don't need to follow every thought. You don't need to trace every idea back to its beginning. The motion continues on its own. The universe keeps turning, and you can simply drift within it. Calm, quiet, present. And if you're still here, still listening, still drifting with this gentle current, leave a soft 3 in the comments, just to let me know you made it all the way to the end. And wherever you are in the world tonight, remember this: you are not standing still. You are gliding endlessly through a universe that has never stopped spinning.